I'm gonna get $100.
I'll pay you $100.
I would love that.
Oh,
Take that back, Diana, take it.
okay, then.
Oh. And now, back to final review. Okay, ladies and gentlemen, I'm sorry, there's a typo on this, so I want to make sure that you know what the typo is. The final will cover the following chapters. That is not a typo. But the final will only be worth a test grade, not a test and a half. So it's worth a test grade. It will be all multiple choice. The questions are going to be broken down as followed, and it is going to be calculator permitted on the whole thing. So chapter 6, you permitted, meaning you can have it.
Permission.
You will have 3 to 5 questions over chapter 6. If you're wondering what type of questions will they consist of, we will review the different types of questions that could be chosen to be put on the final. So same with chapters 7 through 9. Chapter 10 will be the majority of the final, with really more towards 15 questions over conics. So that's what we're going to spend a lot of time reviewing, both today and Friday, but we're also going to sprinkle review 6, 7, 8, and 9. For the next 2 weeks, this is our schedule. Really, today we're on May 26th. But if you need help after you're completing the review packets, I will be here. And when it says office, that's just in this classroom from 7 to 8 June 1st, 7 to 8 June 2nd, and 7:30 to 8 June 3rd. I wouldn't anticipate you would need me June 4th because your final is on June 3rd. It's the second final. So your final will go from 9:45 to 11:45. Wait, right?
11:30.
11:15.
Oh, yeah.
I can't do that. There we go. Dang it. So that's going to be an hour and a half. You will not, it is timed. So I will be distributing the final right away at 9:45, but we aren't going to do questions before the final. So if you do have questions, please make sure that you come in during one of those times to get it answered. I do want to make sure that you guys have the full time allowed to take the test. There's some ideas that you could do for additional review, especially reviewing past group works or notes, really more for chapter 10. That will help you as you prepare for chapter 10. Also, I am going to be giving you back your past tests. So reviewing your past tests would be helpful, especially if you forgot in chapter 6 how to graph a polynomial. We will review it, but you did do it on your test 3 or 4 times, so you can look back at those examples as well. Any questions from the final review? Okay, then my goal today is I'm going to walk this through with you. Some of them I might have you do with your partner, but when we're finished, I'm going to give you the remaining time to work on homework for tonight, which will match pretty closely what we do here in review so that you can kind of try it on your own and see without the help, can I complete this and feel good for the final. Another nice thing about the final is you will be given this box of formulas. So you don't have to memorize vertex form or standard form for the conics. They will be given to you. You will have to be able to put an equation in these forms like you have been on the homework, and you will have to be able to identify what type of conic you have given an equation not in that form. We've been doing this a lot though, so let's see if you guys can warm up with numbers 1 through 7. Label the following as a circle, parabola, ellipse, hyperbola, or a line. Go ahead, take a few minutes and try this.
I'm sorry, I don't know if you got to send me a message. I was taking one story, I ran over time, took her down to that. My lunch got stolen, so it's a lot of different things, but I'm sorry, I forgot to respond. But yeah, super much. It's not very famous. Yeah.
All right, guys, let's see how we did. Number one, what do you guys think? What'd you get? Parabola. Good. There's only one squared term, so it would be a parabola. In fact, let me get some Road to Excellence out here. Today I brought in cookies. On Friday, I'm going to bring in different types of treats for Road to Excellence winners. So raise your hand for number. So Kate, I heard you answer that one, so I'll give you number one. Number two, could someone raise their hand and tell me what type of conic is it? Hunter.
Ellipse.
Ellipse. Nice. Because it has a positive x squared and a positive y squared with different coefficients. Nice job, Hunter. How about number three? Daniel? Hyperbola. Awesome. Because it has one positive and one negative x squared and y squared term. Nice. Number four. Someone raise their hand. Tell me, Sarah Joy? Yeah, yes, it's a line because there are no squared terms. Nice job, Sarah Joy. How about the next one? Number five. Lily?
Hyperbola.
Yes, we have one positive and one negative squared term. Perfect. Tristan, how about number six? Nice. It's a parabola because there's only one squared term. All right, Lily, Tristan, and one more. Number seven. There. Nice. It didn't fool you. You do have two positive x squared and a y squared, but since it's the same coefficient, we could divide that 7 away, and that's the circle. Nice. All right. Looking at the next portion of the review, you're given an equation, and you have to put it in standard form, or the directions should say vertex form, because if it's a parabola, that's the most helpful form to graph. So let's take a look at number one. First of all, what would be the type of conic that it is? Parabola. Awesome. Once you know it's a parabola, what might be helpful is to write down the form that you want to put all the numbers in. So the parabola vertex form is y equals a times quantity x minus h squared plus k. And that's going to kind of help me to just rearrange the numbers to put it in that form. What would you do with the -1 first? Annabelle? Nice. Move it to the other side, so just add 1. And then we have y plus 1 is equal to negative x squared minus 4x. Now I can see in the form I'm moving it to, I'm going to have something squared. That tells me I have to complete the square. But what do I have to do before I can complete the square here? Annabelle? Nice. Factor out the -1. And I have to do it from both x values. So I take out that -1, and then I would have quantity x squared plus 4x. Oops, and I'll leave myself a space to complete the square. Now I can complete the square. What do we do with the number 4? Good, divide it by 2, and then do what with it? Square it. Awesome. So 2 squared is 4. What am I really going to add on the other side, though? Good, -4. Because I have to take into consideration -1 times 4. Then I start moving these numbers together. So I have y minus 3 equals, I can factor this down, -1 times quantity x plus 2 squared. And then the last thing I have to do is move the 3 over. And then it'll be in that proper form. So I have y is equal to -1 times quantity x plus 2 squared plus 3. What would be the vertex? -2, and how about the next number? 3, good. It's not in parentheses, so we don't have to take its opposite. It's actually exactly what we see. So I can go and plot the value -2, +3. Looking at the negative, is the graph going to be facing up or down? Down. And do you guys remember the pattern? If I go right 1,
One.
1 and then 1 times, yep, 1 times 1, so over 1, down 1, or if I go over 2, I would go down how many? 4, good, or if I go over 3, how many would I go down? 3 squared. 9, good, so I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I can just reflect these, and I've got my parabola shape. Number 2, turn to your partner and tell them what type of conic it is.
No, I think it's a hyperbola. Yeah.
All right, I heard it. It's a hyperbola. Awesome. So if I'm using the formulas given, the hyperbola has 2 different standard form equations. You guys know that's because it could open left or right or up or down. The first one, the x value is positive. In the second equation, the y squared value is positive. So I'm going to start using which form based off of the squared term that's positive. So if I look at number 2, is it the x squared or the y squared that's positive? X squared, good. So I want to make sure to put that first. Then I can line up my x's, x squared minus 4x. I'm going to line up my y's, but what am I going to have to factor away from the y values? -9, good. And then I have y squared. What's 18y divided by -9?
2y.
Close, super close. -2y, I just want to be careful with that because that can affect my center. So you might even want to just write it underneath. I don't know if that helps, but just kind of, the positive divided by the negative, just to keep that there. Now we can complete the square. So again, I take half of the middle term and square it. So half of 4 is 2. 2 squared would give me 4. I have to make sure to add 4 to the other side. Inside the parentheses, I take half of 2, which is 1, and square it. I'm going to add 1 inside the parentheses, but what am I going to add to the other side? -9, awesome. Don't forget that distributive property. Then I can factor this down, so I have quantity x minus 2 squared minus 9 times quantity y minus 1 squared is equal to 18 minus 9 gives me 9. But looking at the standard form of the equation of a hyperbola, what is the equation equal to? 1. So how am I going to make this equation equal 1? Good. Divide everything by 9 and then reduce it. So I have quantity x minus 2 squared over 9 minus 9 goes into itself 1 time. So I have y minus 1 squared over 1 is equal to 1. And turn to your partner, the person with the most pets in the group. If you could share what the center is and how you would start graphing this.
I have 0. I have
2 dogs.
So it'd be 2, 1, and then A, B would be 3, 1. Left and right 3, and then up and down 1. And then down.
All right, I heard good centers and A and B values. Should we be drawing a rectangle or an oval through these points? Rectangle, good, because it's a hyperbola. And then I'm going to draw diagonals through the corners. And then a diagonal through that corner. And the last thing I have to answer is this graph going to open left and right or up and down? Left and right. How do we know that? Nice. The x value comes first. So it's going to go in the direction of the x-axis, which always goes left to right. So I'm going to take that point, open it to the right, as wide as the asymptotes go, and take that point and open it to the left, as wide as the asymptotes go. Number 3, what type of conic is number 3? A circle, good. Now, if it's helpful, you could write the standard form of the equation of the circle. That looks like x minus h squared plus y minus k squared equals r squared. For me, sometimes that's helpful because I'm trying to see, should I make this equal 1 or should I make it equal a number? For a circle, I want to make sure it equals a number. So I'm going to move the x's together.
Wait, number 2 was, sorry, left and right.
Yep, because the x came first.
Okay.
For this circle, is there anything I need to factor away from the x's and the y's? No, because they both are by themselves. So this one's a little bit nicer. I can go ahead and just complete the square. So take half of 8, which is 4, and square that. So that comes out to be 16. For this one, I can take half of 10, which is 5, and square it, which comes out to be 25. But I do have to make sure that whatever I've added, I add to the other side. So I have to add 16 and add 25. And now I can go ahead and start factoring this down. Is this going to be an x minus 4 squared or an x plus 4 squared? Minus. How do we know? Good. The first term's negative. Awesome. So we have x minus 4 squared plus y minus 5 squared equals negative 32 plus 16 is negative 16 plus 25 comes out to be 9. Turn to your partner and see if you can identify, this time, the person with the least amount of pets. You tell them what the center and the radius would be.
Hold
5
on.
and the radius.
I'm trying to probably back. One. Maybe we just down my
7, 8 at that point.
down my
All right, guys, your center should have been at 4, 5. Radius is 3. And then you graph your circle. Number 4, what type of conic is number 4? It's got a positive 4x squared and a positive 16y squared.
ellipse.
Ellipse, good. So I might write down the form of an ellipse to help me see what do I have to make these numbers match. It's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So that tells me, hey, let me move the x's together first so it helps me easily identify the center. So I move the 4x squared and the 16x. I'm going to move those out first, but what am I going to factor away from those? Good, factor away 4. So I have 4 times quantity x squared plus 4x. And then what am I going to factor away from the y's? 16, good. So I have plus 16 times y squared minus 2y. And then I still have equals negative 16. When I complete the square, I take half of 4, which is 2, and square it. So I'm going to add 4 inside the parentheses, but what am I really going to add on the other side? 16, good. 4 times 4. So I'm going to add 16 over here. Inside the parentheses here, I take half of 2, which is 1, and square it. So I'm going to add 1 here, but what am I really going to add on the other? Good, 16 again. Because, again, we had that GCF on the outside. Now I factor this down, and that would give me 4 times quantity x plus 2 squared plus 16 times quantity y minus 1 squared is equal to 16. There.
Why is it 2y not 4y?
Because I moved the y's over here. So 32 divided by 16. Yeah, I kind of rearranged them around. Then what's the last step I need to do, guys?
Divide by 16.
Good, divide everything by 16 and reduce. So 4 goes into 16 4 times, 16 goes into 16 1 time. And so I have quantity x plus 2 squared over 4 plus quantity y minus 1 squared over 1 is equal to 1. What would be the center of this ellipse?
Negative 2, 1.
Good, negative 2, 1. How far am I going to move left and right? 2, good. And how far am I going to move up and down from the center? Good. So I use those key features and I go negative 2, 1. I go right 2, left 2, up 1, down 1. And what shape am I going to draw through these points?
Oval.
Yes, an oval. And that's it. All right, number 5 is a review question. Let's see if we can answer what type it is. What type of conic is that one?
Hyperbola.
Hyperbola, awesome. Since it's a review, try this one all on your own. I'll be walking around if you need help. Raise your hand.
Well, is this one a hyperbola?
It is.
For the pain value, do you want us to put it as like what it would be or like what it is now? Just like the squared version of now.
Oh, for this one, that one you start with what it is, so like you can get a value and what to do with the four. And you put it into the equation, so you can do that.
Oh, yeah, I totally forgot. So this is not-
So right here is going to be 6y plus 9.
Yeah, you're gonna have to add 9.
Generally y minus 3.
Yeah, but you also have to add 9 to the other side.
How do this work? This
You want
minus.
to factor out the negative one before you complete this one. There you go. And so you 16 divided by
61, 44.
negative one. So you plus 4x. And then how are you gonna add to complete the square?
4.
And then you're gonna add the other side.
Wait, just 16 or negative 16. Negative.
You factor that down, you divide everything. and you take the total. All right, guys, if you got that one, you can go ahead and try the next one while I put the answer up here. But you should make sure that you added 9 to both sides of the equation. And added negative 16.
If you have it correct, your correct equation should be y minus 3 squared minus quantity x plus 2 squared over 4 equals 1. Do check to see that you have your center as negative 2, 3. Because you have to look what's next to the x value and then what's next to the y. Kate,
It's plus 2. Oh yeah. I just keep forgetting the numbers. For like the -16.
the negative 16.
I did a -4x because that's the 16.
Got it. And then we should go up and down 4. Because you go the square root of 16, right and left 2. And then you draw your diagonal. And this graph should have opened up and down. So it opens this direction and that direction. Sarah, drawing.
How did you get the 1 from 16?
The one
Divided by 4 is 4.
the 1 from 16.
Divide
Oh.
16.
So when you divide this by 16 and this by 16 and this by 16,
Oh, well, yeah.
the 4 goes into 16 4 times. Good. All right, let's see if we can think backwards with hyperbolas. So maybe on the final you'll be given a graph and you'll have to identify the equation. Well, first of all, what would be the center of this graph? Good, -2, +4. The A value is how far you have moved left and right from the center. So how far are you moving left or right from the center? 4 units, good. The B value is how far you move up or down from the center.
Wait, why did you -2?
Because I calculated it wrong. Thank you, Will. -3, 4. -3, up 4. Thank you. Then the A value is 4. What would the B value be? 2. Good. The A value is 4. And then if I think about the equation, this one opens up and down. So should I have the X value first or the Y value first? The Y, because it's going up and down along the Y axis. So the equation is y minus k squared over b squared minus quantity x minus h squared over a squared is equal to 1. I want to make sure that I put my k value in as what's being next to the y, and I put my h value in as what's next to the x. And then I've already identified a and b, so I just need to square them when I pop them into the equation. So my equation will look like y minus 4 squared over b squared, so over 2 squared.
4.
Yep. Minus quantity. What happens if I take x and I minus a -3?
Plus.
Good. It's going to become +3 squared over 4 squared, so you could say over 16 is equal to 1. And that would be the equation that I would choose if it was multiple choice options. Last review question from chapter 10. Consider the standard form of a circle, which is given to you here. What is the area of the circle? And this is really a matter of just knowing the formula. How do you find the area of any circle? Pi r squared. How about the perimeter? What's the formula for the perimeter, also known as the circumference of a circle? Nice, 2 pi r. Now, I don't know what r is, but if the equation did give me r, I could pop that in.
What is the perimeter?
Perimeter is the circumference. It's the length around the
Oh,
circle.
it's the circumference.
Yep.
They're the same thing.
All right, that's it, chapter 10. Now we've got 2 more chapters to review, and then you guys will have time to work on homework. Zach,
Wait, isn't circumference like 2r?
2 pi r.
Oh,
So if I had a perfect circle, like this mason jar here, for example, and I wanted to see what's the length around the lid, I would determine what's the radius of this, and then I'd multiply it by 2 pi, and that would tell me how many,
what's the long line in the middle?
that's the diameter.
Oh,
So yeah, the circumference could be considered d times pi,
okay, my bad.
because the radius is half the diameter, so 2 radii equal the diameter. All right, chapter 6. So that's the new stuff. This is the old stuff. But we start with the furthest chapter away. You guys can do this.
I think we should just have a chat with that.
I think
Wait,
it's
is this
7.
long?
Number 1 is
Huh?
7.
Is this long?
Chapter 4, no, chapter 4 in college algebra is log. Chapter 8 in algebra 2 is log, so we'll review that on Friday. All right, write each polynomial in factored form. Do you guys remember the rule that if you have a squared minus b squared,
No.
that's good for geometry. A squared plus b squared equals c squared. L,
Oh, I just have a question. The test is multiple choice, right?
it is.
So I have a 25% chance of getting it.
You have, there might be an E, none of the above. So you have a 20% chance. Right, get it right.
There's still a chance.
But there's still a chance. All right, number 1. First thing I might want to check for is a GCF. There is no GCF between 100 a squared and 121. So the next thing I would look for is, does it match this pattern? It does. What value squared gives me 100 a squared? 10a, good. And what number squared gives me 121? 11, good. So if I factor this down, it becomes 10a minus 11 times 10a plus 11. And that is it. What did you say, Robert?
I'm confused when I did so well.
You did so well on this test?
Yeah, I got 90.
Well, sweet. This will be an easy opportunity to do well on the final. Yeah. Number 2. Number 2, this looks like something squared and then an x. And we can actually factor it in the same way. There is no GCF between 3, 28, and 9. So I start by asking, the last term's positive. Am I going to have the same signs or different signs? Same. What are the same of?
The first time.
Good. Then first one, minus and minus. What times what would give me 3x to the 4th?
3x squared or cubed. And then, wait, what?
So you want to make them the same variable?
Oh,
But yeah, it would be 3x squared.
what if like the first number is 3x cubed?
Then you can't factor it in this way. So it has to be the same variable in order to factor it like this. And then if I think about factors of 9, what are factors of 9?
3 and 9 and 1.
3 and 3 or 9 and 1? Good. Do you guys remember the trick that if there's no GCF to begin with, there's no GCF to end with? So could I put a 3 here?
No.
No, so that means 3 and 3 don't work. So I have to choose 9 and 1. But where should I put the 9?
I don't know what that's all.
Good, the right side or the second one, and the 1 will go here. And then I check it. Does the outside and the inside add up to negative 28x squared? Yep, negative 27x squared plus negative 1x squared does add to that one. Now there's one last thing I can do here. I'll highlight what I hope you see.
You can factor that down to x plus 3, x minus.
Yeah, x plus 3, x minus 3. And now we are finished. All done. All right. On to,
Why don't we start with chapter 10?
why didn't we start with chapter 10? You guys like chapter 10?
Yeah.
Yes.
Oh, that's good. Because that's the
So
majority of what the final's over.
Yeah, that's what I'm gonna.
We can have the final be a test and a half.
Do you guys want that?
Yes.
No.
No, because my mom is the.
How do we can choose how much we want it. So like,
You can do that.
take a vote. If we have it take 1.5, that's great.
But the thing is, we'd have to vote between all the Algebra 2 classes. So I'd have to vote with Miss Casey
Basing our
also.
lowest test grade.
No.
No.
My lowest test grade.
All right, guys. We'll talk more about this later. Let's review how to graph polynomials. I need to give you guys like a quick recap of notes. If you have an odd degree polynomial, then the opposite ends or the ends of the graph will go opposite directions. If it's an even degree polynomial, the ends go the same direction.
Oh, I remember.
This is end behavior, really. So let's go ahead and let's just write that. Odd degree polynomial And math words are sometimes confusing, so I like to see an example, something like this. That's an odd degree because you have x cubed. Odd degree polynomial have ends that go opposite direction. So they're either going to go down, up, or they're going to go up, down. This one starts up and goes down, so I know that it's an odd degree polynomial. Do you guys remember what distinguishes the difference between the down, up, or up, down? What's in front of the first number? If it's positive, it's going to go down, up. If it's negative, it's going to go up, down. So we say if it's a positive leading coefficient, basically just meaning if it's a positive leading number. So example, if I have y equals positive x cubed, the ends are going to start down, go up. Versus if it has a negative leading coefficient, then it's going to start up and down. And an example of a function that would look like y equals negative x cubed. Now, if it's not an odd degree, what else could it be? An even. So if it's an even degree polynomial, example, something like y equals x squared, then it's going to have ends that go the same direction. And in the same fashion, they're going to either go up, up, or they're going to go down, down. What type of leading coefficient do you think it would make an up, up? Positive. Good. So if it's a positive, and I'm just going to say lead ditto. Example, if you have something like y equals x squared, it's going to go up, up. Versus if you have a negative lead coefficient, like negative y equals negative x squared, then it's going to go down, down. Okay, that was a quick recap of review. Let's see if we can answer some of the questions with that snapshot. Complete all the information for the given graph. Do you guys remember where to find the zeros on the graph? Good, on the x-axis. So x equals 1 is a 0, x equals negative 2 is a 0, and x equals negative 3. For the factors, good. So Will remembers that if x equals 1 is a 0, then you can take the opposite. So essentially, if I wanted to subtract 1 from both sides, x minus 1 equals 0. So x minus 1 is a factor. That's actually going to help us for this right here. If it says, what's the factored form of the polynomial? If I have x equals 1, then I know x minus 1 is a factor. If I have x equals negative 2, what's going to be that factor? X plus 2. And how about from x equals negative 3? Yeah, x plus 3. So here's my factored form, almost, but I need to know, is this going to be a positive or a negative? How do you guys know that?
Ends down.
Good, it ends down. I love that. You could just look at it in that way. It ends down. If it ends down, it's always going to be negative, even if it's an even degree polynomial. So this is a negative leading coefficient, so I want to make sure that I put a minus sign in front. Is this an even or an odd degree? Odd, because it has opposite directions. And so the way to check that is if I call this to the first power, this to the first power, this to the first power, if you multiplied this out, this would be a y equals negative x cubed, dot, dot, dot. Because 1 plus 1 plus 1 gives you 3. Now there's something else that allows us to know that each of these were 1. And that's because the graph passes through these zeros. If I look at the next example, what's that zero value that's at -3? This one didn't pass through. This one bounced. So we're going to talk about how that makes your function different. But first, turn to your partner and tell them what are the zeros of this function.
Wait, it's back.
Oh, we're not.
No, okay.
Okay, once you have the zeros, -3, -1, and 1, see if on your own, if you can create the factors. I'll start you with one of those. Okay, if you have -3, -1, and 1 are zeros, then x plus 3, x plus 1, x minus 1 are going to be factors. Now, if I look at the ends of the graph, it starts up, ends up. So is it going to be a positive leading coefficient or a negative? Positive. So I want to make sure that this guy is positive.
Wait, for number 3,
Uh-huh.
was it positive?
It was negative
Why is it negative? Oh,
because it
and-
started up, ends down.
And what if they both end down and it's still negative?
Then it would be a negative leading coefficient, yeah.
Okay.
Is this an even or an odd degree function? Even. So right now, if I looked at 1, 1, 1, that would make 3. So something's incorrect, and it comes from this right here.
Is that to the second?
Yes, how do we know that x equals -3, or really the factor x plus 3, that guy right there?
It bounces. So it's
Yes,
square.
because it bounces. Awesome. So if the graph, so since I'd say the graph bounces at x equals -3, therefore x plus 3 has an even degree. Even.
So the square.
Yeah, it'd be squared. You could even say to the fourth, that would be fine too. Because you want to make sure that when you add up all of these exponents, 2 plus 1 plus 1 gives me 4. So that makes it an even degree. Annabelle. Yeah. All right, the last thing that is important to remember is the maximum amount of turns the graph could take. So I'll go ahead and write this down. The maximum turns is equal to the degree of the polynomial minus 1. So if I look at this graph, it has 1, 2, 3 turns. 1, 2, 3. And that makes sense because the degree of the polynomial is 4. So it should have 3 turns. Okay, that's the review you need to remember from chapter 6.
There's another page.
This is practice. See if you can answer these questions based off of that review. Try it on your own, and then we'll check our answer. By the way, if there's no exponent shown, what's it understood to be? 1. Good. So x to the first, x plus 5 to the first. Kate?
So for this, it doesn't.
So what's the total degree of the function?
Oh, you have to add one.
That will tell you the highest degree.
Because all the exponents. All the exponents get. All the exponents together. So all the exponents together minus 1.
Oh.
So all the exponents just equal 9 and minus 1. So that was what it was.
You guys can do
That's
it.
what I'm
You
saying.
can do this. All right, guys. Number 5, the answer is false. It bounces at only 1, 0. 6 is false because it's y equals x to the 9th. What makes it what?
4.
Because it's an even degree, there's only one of the degrees that are even. There's only going to be one that would bounce.
Why is it just square?
Oh, it doesn't really have an effect. It's just if it's even. So it could be 2, it could be 4, it could be 6. It's just the fact that it's even. There's only 1 0 that it'll bounce at. Good question.
Why would I go to the both going up because it's odd?
No.
So if I look at the degree is it's an odd degree, and it has a positive leading coefficient.
Oh, so they switch. And the-
So yeah, it's going to be the opposite ends. It's going to go down, up.
Okay.
So let's go ahead and let's graph this to the best of our ability. So what are my 0 values going to be?
-5, -1, 2.
-5, -1, 2, and there's one more.
And 0.
0. Awesome. So if you're wondering how do we find those 0 values, you set each of the factors equal to 0 and solve. So we get x equals 2, we get x equals -1, we get x equals -5, and we get x equals 0. Then we start at the ends of the graph. How are the ends going to behave? Down, up. So it goes down and it goes up. There's only 1 0 that it will bounce at. Which 0?
1.
-1. Good. So at -1, I know it's going to bounce, and I just like to kind of mark that. The rest of them, it just passes through. If it's an odd degree, it passes through. So it's going to pass through, it's going to bounce, it's going to pass through, and it's going to pass through. And that's a sketch. Okay, from chapter 6, only of those types of questions, there will be 3 to 5 on the final. More like 3. On to
Can I take a brain break?
well, this is going to take about 5 minutes, and then you guys have kind of 20 minutes to
Oh, okay.
either relax or do. Chapter 7, in my opinion, goes pretty quickly. Do you guys remember if we have a negative exponent, how that affects the number?
Over 1.
Put it under 1. Good. So this is going to be 1 over 4 to the 3/2. Now, do you guys remember this is actually a radical? Do you remember if it's going to be a square root or a cubed root?
Oh, it's like something with the first, the second.
Just
The
one.
number in the bottom
It's the X.
is the index. So it's going to go like this. It's going to go square root of 4
Maybe we should do chapter 8.
and then cube. We do chapter 8 and chapter 9 tomorrow,
Oh,
Friday.
They're having a long.
All right, what is the square root of 4?
2.
2. What is 2 cubed?
8.
8. So the answer is 1/8.
Wasn't there another way to write it besides that way?
Yeah, but this way is more helpful. Number 2. Try number 2 on your own. All right, this should have been the cubed root of 8, quantity squared, also known as 4. Now, you guys, you do have your calculator, so like you could technically just do 8 raised to the 2/3 power, and that'll tell you it's 4. So, I mean, you know, there's that too. Number 3, do you guys remember how to simplify radicals? Take out the perfect square. Good. Do you guys remember the trick that works with the variables?
You do like the 2 into the 7.
Yes, there's an invisible 2 here, and we ask how many times does 2 go into 7 evenly? How many times? How many times does 2 go into 7 evenly? 3. And how many remainders do we have? 1. So there's an a to the first underneath. How many times does 2 go into 8 evenly? 4. So there's a b to the 4th on the outside. Are there any b's underneath? No. Now, some of you liked the factoring tree. Some of you liked taking out perfect squares. Some of you liked a mix of both. Kind of, it was your preference. If you use the factoring tree, you're looking for 2 of the same factor since there's an index of 2. So 500 is 5 times 100. 100 is really 10 times 10. I found 2 of the same factor, so I can take it out. And then what do you do with any remaining numbers? Put underneath. Now, those of you who are perfect square people, you would have taken out the square root of 100, which is 10. And that's my answer. I should probably bring it closer together. That's going to show up. Number 4, if you have a cubed root, how many of the same factor do you need before you can take it out? 3. Good. You can still do the trick with the variables. How many times does 3 go into 13 evenly? 4. How many remainders would I have? 1. Now looking at 24 or negative 24, if I just look at it as 24, 24 is really 8 times 3. Yeah, 8 is really 2 times 4, and 4 is really 2 times 2. So if I lined up these numbers, 24 is really 2 times 2 times 2 times 3. I found 3 of the same number. What do I have to remember if it was a negative?
The I.
Oh, that's good if it's a square root of a negative.
Negative.
But yes, if it's a cubed root, negative 2 times negative 2 times negative 2 is what would produce negative 8. So I've got to take out a negative 2. And then 3 just stays underneath the radical. So it's negative 2x to the 4th cubed root of 3x. That's it. I should probably bring it closer. All right, number 5. What do you do if you have a negative exponent? How do you make it positive? Good, bring it to the bottom. So this is x squared over x to the 6th y cubed times y to the 4th. When multiplying two numbers with the same base, like a to the nth times a to the nth, what do you do with the exponents? Add them. Good. So it'll be a to the m plus n, which means what's going to happen to the y's? It's going to become y to the what? 7. Good. When dividing two numbers with the same base, like the x's, what do you do with the exponents? Subtract. Good. So 6 minus 2 will give me what? 4. And I want to make sure that I keep it in the denominator because I have to take the higher number minus the lower number. Or some of you who are kind of more critical thinkers, you could think x times x times the 6 x's. And you can see x to the 4th is left in the bottom. What's left in the top? 1. Good. Any number divided by itself is 1. So it'd be 1 over x to the 4th, y to the 7th. When you raise an exponent to an exponent, do you multiply, add, or subtract? Multiply. So if I think of 3 to the 1st, 1 times negative 2 gives me negative 2. What's 5 times negative 2? Negative 10. Good. So I have 2x to the 4th times this stuff. If I have a negative exponent, I could technically take away those parentheses because I distributed. But if I have a negative exponent, how do I make it positive? Put it under. So just bring it to the bottom. So 2 has a positive exponent. X has a positive exponent. But I'm going to make 3 squared and x to the 10th in the bottom. And what is 3 squared? 9. I have 2 at the top. What am I going to do with those x's? Subtract. And where, so 10 minus 4 is 6. But where is x to the 6th going to go? In the bottom. That took about 4 minutes. Last question. How do we solve radical equations? Basically, just isolate the radical. What do you do with the minus 10? Add it. Good. And we have the square root of 3x plus 1 equals 10. How do I undo a square root? Square it. So the square cancels out the square root, and now I have 3x plus 1 equals, what's 10 squared? 100. Good. Then we solve for x, so subtract 1. And I get 3x is equal to 99. Divide both sides by 3. And we get x is equal to 33. How do you check it?
Okay.
Just plug it back in. 3 times 33 plus 1 minus 10. I would see, does it equal 0? And it does. The square root of 100 minus 10 equals 0. So it's 33. All right, I have some good news for you. You do have homework tonight, but I'm going to ask that you only do the odds. What we did right here is the most review. So you guys did great. You stuck with me for about an hour. So tonight you're just going to do the odds. That means when you come into class on Friday, you're going to start working through the evens with a partner, and then we'll finish up the last 2 chapters of brief review. And then your homework will be to finish up the evens if you didn't finish them in the time I give you in class, and then final review part 2. And then you guys know your final is next week, Thursday. So you guys can go ahead, download that homework, begin working on the odds. You do have all the answers, so you can check on those. Yeah.
Another chapter.
You already went, Zach.
What did you say?
Chapter 9,
I'm gonna go first.